Okay. Somebody grab the door. I think I'll go ahead and go. Grab the door when you come in. Go ahead and get started. Oh, okay. All right, we'll go ahead and get started here. Hey, everybody. Thanks for coming. It's the last day here. I guess everybody's kind of winding down. We're in the home stretch. I think there's just 2 more sessions after this one, right? I don't know if it's better to go at the end of the conference or at the beginning. I was kind of jealous of the people who went first because they got it over with and you can kind of enjoy the conference. Whereas I've been like hiding the whole time, tweaking everything and, trying to make sure, worrying about the smallest little things, but it's hard to get over that. Anyway, my name's Paul Novaries. I'm what they call a technical account manager at Docker. I do post-sales work with customers and partners. I kind of make sure the customers are getting what they need in their adoption of Docker. I work with partners to make sure their guys are enabled to understand the product. So just a lot of networking with people, relationship building, and stuff like that. Today we're going to talk about user namespaces and Seccomp, both of which are relatively new features in Docker. They were added both in 1.10, which actually is kind of ancient history in some ways, but they're still not kind of underutilized in my opinion. Let's see. Why is this not advancing? Here we go. Advancing. We'll do it this way. Yeah, computers. Why are my bullet points 2 different colors? 2016 and bulleted lists still don't work. Anyway, so just to give you a couple of points on the audience that I was anticipating and the assumptions I'm making, the discussion is mostly aimed at ops people, guys who want to, just increase the security of things running in their data centers, but I think there's going to be some good stuff for devs to be aware of as well. The assumptions as far as skill level, your familiarity with Docker, it's going to assume that you're at least familiar with Docker Engine. You maybe run a few containers. You might be running stuff in production already. You may be just evaluating Docker to see, is it ready for your data center? Is it ready for your enterprise? You don't need to be a deep, hacker to understand what we're going to be talking about today. We're going to mostly focus on the practical aspects more than do a deep code dive or anything like that. Okay, so we'll cover just some basic considerations about security. We'll talk about containment. We'll talk about namespaces, Seccomp, and if we have time, I'm hoping we can do a little bit of a demo. But if we don't have time, I've prepared for that contingency as well. Next. So container security, right? I mean, it's this term that gets thrown around a lot. If you ask 10 people, you probably get 10 different opinions on what exactly that means, right? I mean, it could mean anything from, can we access the engine securely? Do we have an encrypted, authenticated connection to the engine? We have tools like Docker Machine, even Swarm Mode in 1.12 has a huge amount of help in setting up TLS. If you guys have ever set up TLS manually, it can be like a huge, tedious process. If you mess it up, you don't find out until the very end and you have to start all over. It's such a gigantic pain. So we've done a lot to automate that. There's concerns about what's actually in your image. Is the contents of your image safe? So there's a bunch of efforts around scanning images, looking for vulnerabilities. We have a project called Nautilus in Docker Hub that will scan your images. There's some on-prem work being done as well. There's concerns about the integrity of images, right? I mean, is the image that you've just pulled from a registry, is it what the developer actually completed? Is it what QA actually tested? Is it, what the security scanner actually scanned, right? Has it gone through all of those processes, right? Am I pulling something straight from dev into production? So there's, some cryptographic tools in the Notary project, which actually we have a conference or a session later today about that. But anyway, that gives you some cryptographic guarantees around, who signed this image, who's, seen it, who's tested it, who's, responsible for it. And also things like, is this the latest version of this image, right? There's some concerns about freshness. So the Notary project there helps in that area. And then we'll talk about here today, containment, right? Can we make sure that this image is only going to do what we want it to do, right? Can we stop it from doing things we don't want it to do? So before we talk about that, there's just this concept of this ice. You probably see this slide a lot if you've been to other talks from Docker employees. But basically, the concern is you've got your code, right? This is the stuff that you care about, right? Your business logic, your whatever at the top. But you've got all of this other code that you're dragging along, right? Some of this stuff is stuff you actually need to run your code. Some of it is just extraneous things that are in your distribution, right? You don't even really need them. So there's some efforts to, maybe shave off parts of this iceberg, right? There's things like unikernels that'll, massively shrink it, hopefully. But in the meantime, we also want to figure out if we're going to drag all this code with us, how can we mitigate the effects of it? How can we contain it, right? So right now, as far as containment goes, Docker actually leverages every feature that the Linux kernel provides for containment, right? So we have namespaces, which are basically a limitation on what you can see, right? Inside a container, your view of the world is different than the view of the world from outside the container. We'll talk a little bit more about that. There's C groups, which is basically limitations on what resources you can use, right? We can constrain CPU, memory, etc. And then Seccomp is basically a limitation on what tools you have available, what actions you can take. So none of this is Docker specific, right? These are all tools that are available to you just from the Linux kernel itself, right? I mean, there's nothing, Docker specific. It's not magic. All of this can be applied to normal, uncontainerized processes. It's just that the engine simplifies all of this for you and does a lot of it automatically. A lot of this is happening whether you even know it's happening. So this Gartner report just came out a little while ago. Basically, applications deployed in containers are more secure than applications deployed on the bare OS, because if the container is cracked, you're still limited in the damage that can be done, right? There's, very limited downside to having your processes in containers. There's not been a lot of evidence that doing this makes things worse. And then we're going to see all the benefits you get from it, right? There's a link to this Gartner report at the end here as well. All right, so let's jump into namespaces, right? So like we said earlier, namespaces are basically a limitation on what you can see, right? These, we want to allow these processes to operate normally, right? You've got a process, we want it to do what it does, ideally without modification. But what we want to prevent is that process from being able to do things that the developer never intended it to do, right? So, ideally, your application won't even know the difference that it's in a container, right? It won't require any modification at all. And in an ideal world. So like these horses with the blinders on, they can't see what's going on the sides, but they can see what they need to see, which is what's directly in front of them. They know if the road's going to curve, stuff like that, and it doesn't interfere with their main task of pulling the wagon, right? It's just filtering out the distractions effectively. So the first thing most people do when they have their first Docker experience, right, is they pull an Ubuntu image and they start a shell. And usually most of the tutorials that are out there, the first thing they have you do is look at the process table inside your container, right? And you'll notice, of course, well, in this case, I've got a registry instead of a shell, but that process will have PID number 1. And then if you look at that same process outside the container, it's been remapped effectively, right? That's the PID namespace. And most people are very familiar with that. They're also familiar with the mount namespace because you see that the file system you have a view of inside the container is just a subset of the file system on the host, right? That's all pretty straightforward. So the user namespace is really not that different from that, except what we're mapping, instead of PIDs, we're going to map UIDs, right? So what that looks like is, this is a view inside of a user namespace remapped container. I'm running the registry as root, which is, it has to, if you've ever run open source registry, it needs to run as root. And we have a lot of customers that say, well, I want to run it as a non-root user in case of a breach of some sort. Well, with the user namespace remapping, I have this thing remapped outside the container. It's just this huge UID that nobody else uses, right? The idea here is that if there is a breach, this UID, once it breaks out of the container, this UID doesn't own anything. It doesn't have any privileges to anything. It's basically restricted from doing anything interesting, right? Whereas inside the container, once you're in the confines of the container, that process has the rights to do whatever it needs to. Okay. Losing my cursor. All right, so how do we turn this on? It's real simple. We've got this user ns remap option. The argument there is just a username, right? We provide this doc remap user. You can find it in your password file. It's just a dummy user account. It doesn't have any, like we said, it has no shell. It has no home. It does have a home directory, I guess, but there's nothing in there. And in fact, we're not even going to remap, if you'll notice. We're not actually remapping to that user's UID. Doing this etc sub-UID file, if you had any previous experience with user namespaces, you'll see. Anyway, this file, basically, we're just defining a range of UIDs, right? This is a starting position. It's 165.536, and this is basically the size of the range, right? We need a range of UIDs because we might need multiple UIDs inside the container, right? It's a one-to-one mapping. So UID 0 will get mapped to this UID here, and then it'll continue on. So UID 100 will be 165.636 on the outside of the container. So one-to-one mapping, and again, notice here, up here, we're doing this at engine start time. This is a per engine setting. There's no capability currently to do this on a per container basis or anything like that. Whoop. What happened? Okay. Let's see. It's everything on there. All right, so Seccomp, real quick. Again, like we said earlier, this is the Secure Computing Facility is what that stands for. But basically, this is a way of filtering out system calls, right? We're going to limit what tools are available to these processes. It's a one-way transformation. Once you start a process with the Seccomp profile applied, that process and all of its child processes are constrained by those limitations, right? There's no way to go back. So you can think of it as kind of chipping away at that iceberg, or really it's kind of not really chipping away at the iceberg because all of that code is still there. What it's doing is kind of turning the iceberg so you have like a narrower view of it instead of seeing a big wide side of it. You almost see the narrow stuff. I think that works really well. Yeah. So you're just basically filtering out those system calls that you don't need. Think of it like as a seatbelt, right? I mean, when you have a seatbelt on, you are able to do everything you normally do when you're driving the car. You're not able to get up and move around, but when you're driving a car, you don't want to get up and move around, right? If you crash the car, being able to get up and move around is probably not a great thing. So, taking away that ability is probably best for everyone. So Seccomp started as a way, it's pretty old. I think it's about 10 years old. It started as a way of enabling like grid computing, where you would have kind of this, multiple users submitting unknown jobs for technical computing, right? And if you wanted to, put limitations on what those things were able to do, this was what was developed. So I think Andrea Arcangeli came up with this. He's actually presenting right now in another room. But the original implementation was pretty limited. I mean, basically, it just took out everything except like read, write, and exit, I think. There's been obviously some improvements since then, and now we can do everything on a per syscall basis. Not too many things have used this until recently, but now you see like, I think Chrome uses this to kind of sandbox the Flash player. SSH uses it. A few other projects. So if you look at the default Seccomp profile for Docker, you'll see basically how this works is there's a default action, which in this case is error. We're not going to allow anything to happen, right? And then we're going to go in and come up with a whitelist of what is allowed, right? This is actually the beginning of the default profile. This ships with Docker. It's on by default. You've been running this since 1.10 and you don't even know it probably. There are, I don't know how many, 1,000 syscalls that are allowed, something like that. It's a lot. But the main thing is there was a lot of thought put into which ones were allowed and which ones were not going to be allowed. And the payoff has already been seen. I mean, we can go we actually keep track of the number of CVEs that have been completely mitigated by the default Seccomp profile. I'll show you that in just a little bit here. The other thing to note is it's really sufficient for most cases. I mean, most people don't even run into a problem with this, right? The stuff that is filtered out is the type of stuff that you probably aren't going to be doing inside a container anyway. If you do come upon a case where you run into stuff, a problem, your container won't run, or you come into a situation where you want to, tighten it down even more, you can write your own profiles pretty easily. It's a standard JSON format, and you just pass it to the engine at container creation time, right? This is per container. Right? So you can apply different profiles to different containers, no problem. As far as how you would come up with these profiles, the best thing to do, you work with the developer, profile the app, see what it's actually doing, run some S traces, and lock it down, right? See what syscalls you need and get rid of everything else. So like we said earlier, you already have this. It's running by default. It's been in there since 1.10. There's a security option if you need to pass a custom profile in. If you want to turn it off completely, which I would ask you not to do, you can just pass it like seccomp unconfined, and then boom, you're running wide open. Okay, so I'm going to kind of go back to the iceberg a little bit here. These tools here, the idea is we're just making your software safer in a container than outside of the container, right? There's this big secure by default philosophy that, it's pretty core. It's a core value at Docker. So, we want to make decisions that are going to shrink the iceberg, or, like I said, limit the profile of it without impacting your usability. And that spans across, just the platform, the content we provide, access to containers, all of that stuff, right? It permeates everything. There's similar efforts in scanning, integrity, image integrity, encryption, all of that. The same secure by default mindset is being used in all of those. Like we said earlier, in some cases, code that we know is vulnerable can be run in a container effectively without worrying because the vulnerabilities have been mitigated, right? I mean, we can pull that up real quick. You look at this, you can go to this Docker security non-events page. You can just Google that. There's a link to it in the slide deck as well. There's a ton of things in here that are, well, now I've got the beach ball. There you go. If you go through this list, you'll notice a lot of these will say this is mitigated by this one here, the key CTL problem. That was a couple of months ago. A lot of these are contained by the Seccomp profile, the default Seccomp profile. There's a ton of these, and the vast majority of them are things. Here's another one. Here's one that's, in the interest of transparency, things that weren't mitigated by Docker. But in any case, you can see there's quite a few of these, and we don't have any reason to believe that this list would be longer if we knew about more things, right? There's probably a lot of vulnerabilities we don't even know about that are being partially or completely mitigated by Seccomp. Okay. So demo, right? Everybody likes a demo. What I want to do, we do have a good bit of time here. So I'll probably get into a little bit, but what I wanted to do before that is just let everybody know I went ahead and made a do-it-yourself demo. So if you want to try this stuff at home, just go to my Twitter, pin the tweet there. There's a link to this. It's just a market file on my GitHub. And you just follow along and do this yourself. It just walks you through starting a machine with, if everybody's familiar with Docker Toolbox, or just start one, create a machine with Docker Machine, and try some of this stuff out. All right, so let me get the demo going here. How do I get out of this full screen mode? All right, get this out of here. I'll get some. Oh, wait, I want to mirror my display so I can see what I'm talking.